So we get to this side, and the question says, when is the square root of when is the square root simplified? And you're probably saying to yourself, finally, a very life important question, when is the square root simplified? And we're going to show you right now when a square root simplified. Okay? It is not simplified when you go to decimal. So if I get out my calculator and say the square root of 63 is 7.94837, whatever it is, that's not simplified. Simplified means it's still a square root, but you've taken out any possible perfect squares. So your perfect squares, let's do it red. Your perfect squares are the square root of 1, the square root of 4, the square root of 9, the square root of 16, the square root of 25. I think this is getting repetitive, but I can keep going. And it goes and goes and goes. I think you'll see the pattern. The square root of 1 is 1, 2, 3, 4. And these are important to realize that these perfect squares give you nice integer answers, right? Actually, they give you whole number answers. Anything that's not a perfect square is going to give you an irrational decimal answer. So you look at something like 63 and say, what's the largest number, 1, 4, 9, 16, 25, 36, 49, 64, that goes into it? You say, well, one's not useful. So we need to be bigger than 1. 4 doesn't work, 9 works. Excellent, 9 works, right? So I could say this is the square root of 9 times the square root of 7. Because if you have two square roots together, the square root of 9 times the square root of 7 is just the square root of 63. Now, I could then say this is 3 root 7. Okay? And the slides do it a little bit differently, but this is the bottom line. If I do it two separate square roots, or possibly one larger square root, the whole goal is to say, well, 9's a perfect square because I can make it 3 root 7. This is considered a simplified square root. You might be looking at it and say, doesn't look any simpler to me, which I agree with. Square root of 63, 3 root 7, it doesn't actually look any simpler, and it doesn't change the answer. But you are dealing with smaller roots, and as we go forward, you may be able to do some addition, subtraction, multiplication, division, and the smaller roots will create like terms. We'll get more on that later. Let's look at the second one. Square root of 72, well, 1, no, 4, 4, yes. Square root of 4 times the square root of 18, it looks like. Right? Okay. So that square root of 4, I like that because that's 2 root 18. And I'm feeling, hey, great, look at that, I did it. Well, you didn't actually, because when I look at the square root of 18, 1 doesn't, 4 doesn't, but 9 does, right? So 2 square root of 9 times the square root of 2, okay? Square root of 9 is 3, so that's 2 times 3 root 2, and we know 2 times 3 is 6, so it's 6 root 2, right? Now, why I took 2 steps is because I didn't take the largest number that would go out. I just took the first one I saw, 4. Hey, 4 works, excellent. But I didn't take the largest. If I would have kept going, 9 also works, because 9 times 8 is 72. 16 also works. Well, we know 9 works because we had to use it. But 16, doesn't work. 25 does not work. 36 also works. So we could have done it this way and said that's the square root of 36 times the square root of 2. And we know the square root of 36 is 6. We could have said that equals 6 root 2, right? So if you find the largest one, it'll always work right away to the answer, because I can say, okay, the square root of 2, well, 1 isn't useful, right? So we get that off the board, it's not useful. And none of these go into 2, because the lowest one is 4. Same here, how do we know 7's the lowest? None of those will divide into 7 on none of these square roots, right? So if you don't happen to pick the largest one, then you have to do multiple steps. All right, enjoy the slides.